Alright, for 23 we're going to look at this graph, or this equation graph. So we have g of x equals 3 times the square root of x plus 6 minus 4. So we want to use these words. Let's start with the vertex. So the center, or starting point, is going to be the opposite of this, or what makes this 0. So we get minus 6, and then the outside here is negative 4. So if we were doing a quick sketch of a graph, we'd start at negative 6, negative 4. Okay, and so the parent function is the square root of x, which hopefully you know. Let's do that in green. So the parent function looks like this. And so normally we would just draw that exact shaped curve, but we can't do that because of the 3 there. And because that 3 is going to give us a vertical stretch by a factor of 3. And so as we draw it, it has to be stretched vertically. Okay, and so now if we look at our domain, I'm going to get rid of the parent function. Alright, so as you look at our domain, the way I think about domain is with the vertical line that I move across the graph, and the first time it touches is where our domain starts. And then when it stops touching is where a domain ends. But since this has an arrow, this goes on forever, and so it never ends. So the first place it touches is at negative 6. So our domain has a set of x such that x has to be greater than or equal to negative 6. Our range, we look at a horizontal line, and we move that up the graph, and the first place it touches is at negative 4. And again, as it moves up the graph, where does it stop touching? And since this line goes on forever and ever, it'll always keep going up. It's always touching. Even though it doesn't look like it here, it's touching way over here. So our range starts at negative 4. So it's the y values such that y has to be greater than or equal to negative 4. So I've talked about domain, we've done range, the end behavior. So as this goes to, as x goes to infinity, our y values are going to infinity. Our transformations, okay, so it would be left 6, down 4, and then we have that vertical stretch. By a factor of 3. Now the equivalence, is there another way that we could write this? We can also write this as 3 times x plus 6 to the 1/2 minus 4. So I graphed this on the calculator and put the screenshot in. You can see that my graph was not the best graph in the world, but it's actually the blue line. And so I should have stretched it a little bit more than I did. But that's not important. As long as you show that your graph is stretched, you're fine. But again, it shows that the domain starts at negative 6, goes on forever. The y values start at negative 4. So don't forget to use your calculator to help you out. Alright, so for 24 we're going to graph. And so our vertex is going to be at negative 4, negative 1. So negative 4, negative 1. If you wanted to make a better graph, you could just start plugging numbers in that are easy. So if you go 1 to the right, you get negative 3 plus 4 minus 1. So that gives us the square root of 1 minus 1 is 0. So you know it's going to be a nice dot there. Another good one to plug in would be 0, because 0 plus 4 is 4, square root of 4 is 2, 2 minus 1 is 1. So your graph's going to look like this. So our domain, x such that x has to be greater than or equal to, it starts at negative 4. Our range, the y values such that y, here it starts at negative 1, has to be greater than or equal to negative 1. Alright, so for this one, I'm going to start with the parent function of the cube root of x. So we get 0, cube root of 1 is 1, and cube root of 8 is 2, and then we also have the negatives. So you have this shape kind of like a lightning bolt. And so the reason I want to have those dots on there is so now I know my center is going to be moved at negative 4, negative 1. And so basically all these dots get shifted 4 to the left, 1 down. So I'm just going to start here and go over 4, down 1, over 4, down 1, over 4, down 1, over 4, down 1. And this just helps me get a nice graph. So the red is the graph of the function. So our domain x such that x is an element of all the reals. The range, same thing. So if you do this graph, you don't necessarily need to draw the parent function, but I think it helps on the cube to get a better shape of the graph.